Hi everyone. So let's move on to the next topic of the subject data exploration, feature engineering and visualization. And the subject code is 22AM502. So the next unit consists of feature engineering. So what is this feature engineering and how we are going to analyze the data using feature engineering. Right. Feature engineering aspect is nothing but feature engineering is a transformation which cleans the raw data into features and attributes that better represents the underlying structure of the data. See, more than EDA, what you're going to do is you're going to implement the feature engineering aspect where each and every attribute in the data set is going to be analyzed, and we are going to structure the data accordingly. With the help of a domain expert. So which is all necessary, which is not unnecessary, and which attribute is going to give you a perfect data set. This is all going to be done by whom? Feature engineering. So transformation of cleansed data. See, the cleansed data means you're going to have a data which doesn't have missing values or empty columns or outliers. Clean the data already. Okay, from that you're going to infer certain features which concludes to the proper decision making, okay, or which model should be used correctly or visualization should be correctly used for that raw data. Okay, so we are dividing this feature engineering step into three aspects. One is feature extraction, feature transformation, and feature selection. So these are some steps that are going to be involved in when you are going to use feature engineering. So this is how the workflow of feature engineering going to be. You're going to collect the data from some data sources. We have already seen previously. So what are the sources? It can be private or it can be public. From there you're going to get the raw data. From that raw data you're going to do some cleansing work. Okay, data cleansing like finding missing values, then you're going to look out for some outliers, the normalization. All these techniques are going to be implemented in data cleansing. Then afterwards, EDA comes in place of data cleansing, right? EDA happens here. Okay, after that you're going to do even more processing, which is going to have feature engineering, like extraction, selection, and transformation. And then you're going to finalize it with the model. This data set is going to be entirely a new kind of data set which is going to go into the model. Okay, when you're doing so much of refining process, then your data set becomes a perfect one. Okay, to use. So what does this extraction mean? Feature extraction means the feature is usually used in the original raw data. So raw data which is collected from the internet or any kind of company which is offering your private data is very different, and we cannot use raw data into machine modeling. We use directly, there is no use of using the modeling. Okay, they will not predict correctly, that means. Okay, so we are going to transfer the raw data to a desired form using the feature extraction technique. Okay, the feature extraction is a method of creating a new and smaller set of features. You're going to subdivide a big data set into smaller features, and you're going to do the estimation according to it. Okay, 10 columns are there. I'm going to take which is going to be only useful. Only 2 columns are going to be useful in extracting the data. Only that columns will be extracted from the original raw data set, and then from there we are going to do the feature extraction. We will acquire work in the real world machine problem using the CSV file. You know how to extract a CSV file or an Excel text file or a PDF file, all this. So the popular raw types of data is in which format? It's in a text format or image or geospatial data, or it is in the form of a data type, or it is in a blog kind of thing, or web data, or census data, each and every second of census data. So data can be available in any of these formats where these is called as a raw data. From there you're going to do. If suppose, for example, take a simple example. This is my picture. How are we going to extract data from this picture? So see, the pixel values here is defined as a single numbers, and the inside the picture 8. Okay, the values are given differently, right? So this is how we will identify the picture. Okay, so the machine stores the image in the form of matrix numbers. These numbers or the pixel values denote the intensity on the brightness. Wherever it is not there, it is bright. Okay, or it is in dark in color. Wherever it is that, well, it means that it doesn't have any value or a picture in it. Okay, this is how it estimates from a picture. So the transformation techniques include something called as, so this is all about extraction, right? So then we go from transformation. Transformation information captures about feature encoding and feature scaling, which has different types of data sets which I've already seen, like binary or ordinal or nominal values. So how this is going to work in extraction? This is encoding method. So using this encoding method, how we are going to do the feature extraction? See, if it's going to be a binary, then it's going to have an yes or no value, or the column which has male and female will have only two values, either male or either female. Okay, only two categories of values. Or if it's going to be yes or no question, it's going to be yes, or it's going to be only no. If it's going to be true or false, only two options are there for extracting it. So that is called as binary. What is ordinal value? Ordinal value is nothing but it's going to contain certain orders like low income, middle income, high income. Three categories are there. Low is the least, so 1, 2, and 3, or this can be 0, this can be 1 or 2. If you fetch the value 2, it means it's a low income. If you fetch a value 0, then it means high income. So like that estimate, whether he is studying in a high school. Okay, nominal data doesn't have any ordering. Okay, any specific ordering like 1, 2, 3 and all. It is any categories of ungrouped values. Cat is a specific species, right? It can be only commonized in leg and a tail. Okay, dog, tiger. Okay, is a different idea. This is all about food we are talking about. This is all about animals we are talking about. Okay, can you understand this? Yes. Yeah. This is all about feature engineering, extraction, and transformation. Thank you.